Hi Fazil, it's Ian here. Yeah, so I'm going to show you what you wanted to do there with that grid and under the research tools. I think it's research tools. And I think you might kick yourself when you see how easy it is. Although there are some things that might be worth bearing in mind when it comes to the actual grid measurements. So if we open up QGIS. Actually, I think I've already got it open. There we go. So we open up QGIS. Let's just start with a little study area. Okay, so what I'm going to do is just add the Google terrain and then zoom into a familiar place. Yeah, this area looks fairly familiar. Great. Okay. So you started off by creating a hexagonal grid. You then wanted the centroids for those hexagonal grids. You then wanted a grid line to pass through the center of each of those centroids. The thing is, the distance between the centroids is not uniform in a longitudinal direction, although it is uniform in a latitudinal direction. So let's just show you how I came up with those measurements. So I'm just going to assume a basic measurement first of all. Let's start off by creating a grid. So we're going to create a grid. And actually, before I even do that, so let's just backtrack slightly. This grid is going to be measured in meters. So by changing or by adding a Google Terrain streaming image as our background raster, the program automatically changes to pseudo Mercator, which is EPSG 3857. Now this is in meters, so you could go ahead and just start calculating your grid. So for instance, if we went to Vector Research Tools and then said Create Grid, you'll see it allows you to select meters. Now let's just show you what could happen if you left this in WGS 84, which is EPSG 4326. Okay, now the same thing. Let's go and create that grid. Create Grid. Now you've got some warning signs here. And what this is telling you is that the project projection is in decimal degrees. So if you type in 10 meters here, it's actually going to calculate 10 degrees, and you're not going to get the results you were expecting. So firstly, make sure you have the correct projection chosen. Now pseudo Mercator is fine, but for this example I'm going to use Hartebeesthoek, because that is the South African datum, Hartebeesthoek 94, and we're going to use the meridian or the point of tangency as LO 19, and east north up, that just flips the view. Okay, so now just by selecting that, and you can search for it if you don't have it in your previously used coordinate reference systems, just under the filter box here type in what is that, 102562, and that should take you straight to Hartebeesthoek 94 LO 19 east north up. Okay, and the reason I've chosen this one is because that is the closest point of tangency to the area I'm working in. So we can say OK, and my view will change slightly, but now we got it in meters, and it'll have the least amount of distortion because it is the point of tangency closest to the area we are working in. And that might come up later as well if you are working in a much bigger area. And I'll show you how it actually affects your grid. So let's go ahead and create our grid now. Research Tools, we are going to create a grid. It is going to be a hexagon, and the grid extent is going to be let's just use the same as our map canvas extent. And the spacing, we're going to go for 10 kilometers, so that's got to be 10,000 meters, and that's in both ways, both directions, vertical and horizontal, 10,000 meters. And a temporary layer is fine for my example, because I'm just going to delete all this when I'm finished, but you may want to create a permanent file, and to do that you just click over there and say Save to File and choose a place on your hard drive somewhere. I'm sure you know how to do that. So let's run this and see what it looks like. Okay, there we go. So now we've got our hexagonal grid, and let's just color this up slightly differently so we can see what's happening. So I just right click on my toolbar up here. Actually what you can also do is just double click on the icon, and that's probably a simpler way, and we'll choose a nice some nice green, and then I'll make it slightly transparent, so I'll change the opacity of the color. Now by changing the opacity of the color here, it changes the opacity of the the polygon color, it doesn't change the line color. So that's why I like that option. And there we go. So we can still see what's happening underneath. We can see Cape Town, we can see Paarl, we can see Gerbo, and the further east we travel, we can see a bunch of other things as well. Okay, so the center of our map is kind of this Paarl area here. And I've specifically chosen that for this example because Paarl is very close to the 19th longitudinal meridian. Okay, so in this projection, by choosing Hartebeest hook 94 LO19, the least amount of distortion will happen for your layers. Okay, so your measurements, your perimeters, areas, and calculations for that sort of thing are going to have the least amount of distortion here. The further east and west you move away from your center point, the greater the distortion will become. Okay, so that is something to bear in mind. If you are working in an area, make sure you choose the projection with a meridian closest to the center of your study area, let's say. Okay, so your next task, you were saying, it was to create a centroid. So I'm just going to click on, I've already typed it out here, so click on centroid, select centroid, and once again I'm going to create a temporary layer. You can create a permanent one if you want, and then I will just change the color of this ever so slightly so I can see what's happening. Maybe yellow will stand out. Okay, there we go. Okay, so there are my centroids. Now your request was you wanted a line grid that would travel through the centroids for longitude and latitude. Now that would be easy enough if these centroids were evenly spaced, but they aren't. They are there's a different measurement if we actually have a look at it. We'll zoom in over here, show you what I mean. And what I'm going to do is turn on my snapping tools. Now this is something you might want to use. If you haven't used snapping tools before, just right click up here on a blank spot on your menu bar here, and then scroll down and choose snapping toolbar. And now I want to activate snapping, and that'll just allow me to snap to various vertices and points and centroids, etc. So we need to click on the magnet, turn on our snapping options, click on this option and choose open snapping options, and then select all layers advanced configuration. Now we are going to snap to the centroid, and then we also want to snap to the grid, but we don't want to snap to the vertex of the grid. I want to be able to snap to the midpoint. So I want to be able to measure that distance and then that distance to show you that they are, well, you can already see that they are a different length. So you wouldn't just be a case where you could put in a uniform grid and then expect to get a uniform result. So we are just trying to work out what distance we should put in for our new grid line. So what I want to do is be able to snap to the center point of this line segment. And there is an option here. If you click under vertex, you scroll down and choose middle of segment, that will allow you to now do that. So now you can turn that off. It should go off. There we go. And let's just measure that distance. So we're going to choose our measure line tool, and that pops up with this little measurement box. And we're going to, you see the minute we get close to our centroid, a little pink box pops up, and that indicates that we are snapped onto that centroid. So the distance between there and then the midpoint is essentially the distance between there and there. And that comes out at 8659.511. Okay. And if we go this way, it is close to 5 kilometers, 4999.615 meters. Okay, so that distance from the centroid. So if you went ahead now and you used those two measurements for your vector, so you could essentially go in here, and where's my research tools, and then you type in the new values for a line. So you select line, similar grid extent. Let's just use our existing map extent. Okay, and what was it? It was our first distance, our horizontal spacing will be 8659.511, and then our vertical spacing was 4999. Now I don't remember what it was, point something, but let's just leave it like that for now. We'll create a temporary grid, we'll run that and close. So now it's not quite 100% in the middle, so what we could do then is, first of all, let me change this so you can see it. You probably can't see it. Let's make it a bit, oh, not that fat. 0.4 and a pinky color, salmon. Now you can see it. So what you could then do, okay, now you can see there's your measurements for your grid lines. Is we then select our editing tools. Okay, and there's actually another editing toolbar that we're going to need for this next little section called Advanced Digitized Editing. So just right click again, once again on your open toolbar spot there. Select Advanced Digitizing, and then what we are going to do is we are going to select the whole grid and then select the move option. But before we do that, we want to snap again. So we want to choose our snapping options. So let's just make sure we open the advanced snapping options, and this time we want to use the grid vertex as well. Okay, and then it's just a case of selecting move, click on the first vertex, move it to the first centroid, and there you go. Now if you look at that from a distance, this looks like it's passing through the middle of each of these centroids. So job done, right? Now if you're actually happy with that result and that scale and that accuracy, then your job is done. But if you actually wanted to pass through the center of the centroids, you're going to see that there's a slight issue here. As we get closer to it, zoom in, you'll see that that distance has actually changed. So even though we measured it out up front, the distance has changed. Okay, so it's not going to consistently pass through that centroid. And the only way to do that, if you had a grid this big, would be then to, let's delete all of this, we'll start editing, and let's select all and then delete, would be to actually draw a line for each one. So you draw these lines like this. I'm just going to finish that and then do this one. So I'm just snapping to each centroid. And another one. Now you want to avoid this because I imagine you've got quite a big study area and you don't want to be drawing all these lines in. It's much easier to use that grid. But this is if you wanted to pass through each centroid. We use the editing tool and the snapping tool to snap to each centroid. But I'm already bored of this and it's probably going to take you all day. So let's not bother with that. So I'll show you the next best thing, I guess, is to try and average out that distance. But before I do that, let me show you why it's actually happening. Okay, so let's start off with that measurement. So let's stop editing that for now. We are going to use the measuring tool, and we're going to measure the distance between the centroids and then the middle of the line segment. Okay, so the nice thing about this little tool is it will add up and show you the previous measurements. So let's start here. So you can actually see this measurement is changing. 8659, and the number is getting bigger and bigger until we get to our central meridian, or our point of tangency. Now you'll see that that line will start, that distance will start getting smaller again. Okay, so now it got to 60 around about 19 degrees, and then it started changing. So what you could do is you could measure the total distance from there to there. Alright, and then open up a little spreadsheet. Okay, let's open up that spreadsheet. And then, where can we go? Go length. Oh. Length, columns, and then space or value, let's say. Okay, so the total length is, what's that, 181 kilometers. 859.135. Alright. Divided by the number of columns. So 1, 2, 3, 4, 5. Oh. I'm going to have to calculate. I'm going to have to count these. Right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Ooh, is it 21? I hope it's 21. And then divide the distance. So then we'll just go equals this divided by this. So this is kind of for your best average, right? So it's 8659.959. Okay, so now that is the distance we are going to punch in to that grid calculator. Okay, now that is for the longitudinal lines. What about the latitudinal lines? Now the latitudinal lines shouldn't change. They should be the same. And that's because of the projection we're using is Transverse Mercator. So it's a cylinder. So what we're doing is we're getting a spherical shape, the Earth, and we're projecting it onto a flat plane. And in this case, for Transverse Mercator, the flat plane is a piece of paper or plane that is wrapped around the Earth in the form of a cylinder, and then it's popped on its side. That's why it's called Transverse Mercator. And so the point of tangency is the point that that cylinder then touches the Earth. And you know what? Maybe I should quickly draw this. Okay. Okay, so we've got a round shape that a spherical shape that we need to unwrap and project onto a flat piece of paper, or computer screen, or whatever we're projecting the globe onto. So what we essentially got is we've got our spherical shape, and then we've got a cylinder, so a flat piece of paper, which is then wrapped around the Earth. So if I had to draw that, it would look something like this, and then popped on its side. So this is popped on its side, okay, and it's wrapped around the Earth like this. Okay, not quite like that. And then if you imagine this being a cylinder, I'll try and draw a cylinder. Oh my gosh. Okay, something like that. Okay, so this piece of paper is wrapped around the Earth, and then where it touches is the point of tangency. Okay, in this instance, we're using 19 degrees. Okay, so there we go. So now what happens is, if you imagine at the center of the Earth is a wire globe, and at the center of the Earth there is a globe that's on. Okay, so now this is a light bulb, and it is shining out through the wire globe onto the piece of paper. Then you're essentially projecting the round shape onto a flat surface or a flat plane. And the further you get away from the point of contact, the greater your distortion. So I wonder if I've got different colors I can choose here. I'm not really that familiar with this tool. Can I choose a different color? Something like that. Okay, let's try that. So now this area here is being projected onto that area there, and you can see that that distance is not the same as this distance. Okay, so the further you get from your point of contact, the greater the distortion will be. Okay, so that's basically what I'm trying to get across here. And if we go back to QGIS, when we ran through that little there we go, this little measurement, we saw that the closer we got to our point of contact, which for LO19 is PAL, where we're almost in line with PAL now, it gets to 250. It gets to 8660.250 from a much smaller value, and then starts changing again. And so that's the reason that happens. So kind of a long-winded way of explaining that, but sometimes these are important things to know. Okay, so then it gets smaller again. So point of tangency, least amount of distortion. But what about the latitudinal lines? Well, there's actually zero distortion. Okay, and let's just prove that by measuring these distances. Okay, uniform distances. So nothing changes for latitude. Okay, so that value we're not going to have to change. So if we go back to our little equation over here, not our equation, sorry, the little values that we are going to use, this one can be 4999.526. Enter. There we go. I'm going to drag that off to the side. And I am now going to create that grid. Alright, so let's create the grid. This one can travel, but before I do that, I wonder if I can steal the style. Now delete it. Okay, let's just zoom in like that. Maybe a bit tighter. There we go, that looks better. And run that Research Tools Create Grid again. And it is a line. The grid extent will be same as the map canvas, that's fine. Now horizontal spacing is going to be that average, so it's 8659.959. So that's our best average. It's not going to be consistent across the whole way, but this one will be 4999.526. Okay, temporary, all good. Let's run that. Close. Okay, now we've got a whole bunch of extra ones. Let's move it again. First of all, I want to see if I can paste that style that I stole. Yes, I can. Let's zoom in a little. And we will start editing. I'm going to select everything. And I actually just need to make sure I'm snapping again to the new layer which has been added. Okay. We're going to move everything from that point to that point. And then we can deselect, save, and it should be a lot closer. So there will across this this length still be some issues, but it'll be a bit closer than it was. So you see there's still issues, but on average it'll be much closer to the centroid. So like I said, ultimately if you want it to 100% go through the middle of each centroid, you're going to have to digitize it manually, but if you want to get as close as possible, you can use this method. Yeah, so I mean that turned out to be quite a long video, but I hope you learned something. Let me know if that works out for you. Okay, cheers.